In Math 10, we learned that equations of the form y equals mx plus b, also called slope-intercept form, can be graphed like this. But first we have to define the slope. What does slope equal? First you learn an English phrase. You learn kind of a little chant. Slope is what over what? Anyone? Use letter R, yeah. Okay, so let's write that down. Slope is the rise over the run. By the way, I had a math teacher, and she always did it this way. Even though she spelled rise wrong, she did it like that because the y reminded you that that was the y values, which I thought was quite clever. So I still, whenever I hear rise, I think the y's, in case you get rise and run mixed up. Okay? You also had a formula, which was y2 minus y1 over x2 minus x1. You used that if you only had the points and you didn't have graph paper handy. Now, this year, 99% of the time, Megan, we're going to have the graph paper handy, and so I'm giving you the y2 minus y1 over x2 minus x1 because I'm a math nerd and because I do love that formula, but we're hardly ever going to use it. By the way, this equation, this formula, this slope formula right here, is the Swiss Army knife of mathematics. Just like with a Swiss Army knife, it has all sorts of different ways that you can use it that you didn't anticipate. You'd be amazed with a bit of cleverness just what you can do with that slope formula. If any of you take calculus next year, you're going to find actually you start out with that and derive calculus from it. So it is dear to my heart, but purely because of nerd reasons, Ty, not because of physics reasons. So graph the following on the grid to the left. You can freehand if you want. Later on, we're going to be doing kind of a lab activity. If you're drawing a line on a graph that you're handing in to me, I do want you to use a ruler. If you don't have ruler, you know what, Mr. Dueck? Just let's decide right now. Pause the video. So hopefully you learned last year, but I'll pretend you forgot. Oh, okay, I already see it. Hang on, we got to pause. So how do you graph these? Number one. Y equals 2/3 x minus 4. First of all, very obvious, maybe so obvious that you don't know this. How can I glance at that and instantly figure out that it's a line and not a curve?
There's no squared.
Ah, Connor picked it up. There's no exponents, no squared, no cubed, no weird stuff. In fact, in Math 11 or Math 12, you'll learn that if there's a squared or a cube or a square root, it's going to be a curvy thing, not a nice straight line. So as you learn more and more different shapes, Matt, it's worth having that in your arsenal. I glance at this. That's a line. Not only that, Matt, is the y by itself?
Yeah.
Then this is slope-intercept form, where that's the slope, which we use the letter m for. Mr. Dueck, why do we use m for slope? Because not all math was done by English-speaking people. I believe this was from French, and I think it's the French word for mountain or slope, I think, is why it's an M. And then we call this B, the y-intercept. And although we tend to write it this way, y equals slope x plus b, when you're graphing it, Alex, you do the b first, the y-intercept. The y-intercept here is negative 1, 2, 3, 4, right there. I would put a dot right there. And then from there, I'm going to count the slope. Eric, it's not a helicopter. Thank you. I'm going to count the slope. What is the slope here? 2/3, which means count how? Up to over 3. Up to over 3. Up to over 3. And I can back count down to back 3, down to back 3. You know what? I can go fancy schmancy. I think I can use drawing tools here. Draw a line. Okay, that's way off, but I can fix this. Oh, try that again. Undo. Turn that off. Pretty close. And you know what? Since that's line number 1, I'll put a little number 1 there. What you're going to be doing more this year is not graphing the equation. What you're going to be doing more this year is reversing this. I'm going to give you the graph, Megan. I'm going to say, hey, tell me the equation. What's the y-intercept? Can you please put that where the b is? Can you go rise over run, find the slope? Can you put that in front of the x? Although also I should say, Alex, we're rarely going to be using x and y. We're going to pick letters that make sense. And you'll see what that looks like in a bit. Number 2. Alex, my friend, number 2, is that a line?
Yes.
How do you know? Okay, no weird stuff. Okay, is the y by itself?
Yes.
Oh, hey, this is slope-intercept form. Alex, my friend, what's the y-intercept? 5. What's the slope? Ah, which means count how? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Well, let's see if I can use a ruler. It's really tough for me to draw a ruler on my computer screen because it's slick, it's slippery, and there's a gap. I'm going to try. That's pretty close.
Grade 10 students, last name M to Z.
Okay.
Please head to the mini gym now, please. Grade 10, M to Z, to the mini gym.
Oh, and I'll call that line number 2. In a few days, you're going to have a quiz, and on that quiz, I'm probably going to give you this identical question, but Courtney with different y-intercepts and different slopes, and I'll just say, and label each one, 1, 2, 3, so that I know which one you think is which line, right? Speaking of Courtney, number 3, is that a line, yes or no, and how do I know? Yeah, how do you know? Okay. Is the y by itself? Then this is slope-intercept form, except this is kind of strange. What letter is missing? What letter, what variable is missing? It's meant to be really obvious. The x. In fact, if you said, I'm going to say it a different way, how many x's are there in that equation as a number? You can think of this one, Courtney, as, let's change colors, y equals 0x minus 8. I will never rewrite that again. I will just see that. Now that I've done that, Courtney, what's the y-intercept, my joy? What's the y-intercept? What's b? Yes. It's going to go through there, and here's the key. What's the slope? What does a slope of 0 look like? By the way, Prith, every line is straight. Captain Obvious, thank you for your horizontal line. It's a straight line. That's the definition. A line. Otherwise, we'd call it a curve. Just saying. So, horizontal line. That's line number 3. So, Courtney, I'm never going to rewrite that. I think y equals -8 is a nice short way to write it. But I see, oh, no x's? No x's as a number means 0x. Oh, the number in front of the x is a 0. Compare that, John, with this next one, example 4. Is it a line? How do you know? No funky stuff. No square, no cube, no square root, no sine, no tangent, no any of the other weird stuff on your calculator. None of that. Okay. Is the y by itself?
Yeah.
Well, then this is in slope-intercept form. What's the y-intercept here, folks? This is really the same as, I'm never going to write that again. But yeah, that's got a y-intercept of 0. And John, what's the slope, my friend? Which means count how? Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Slope-intercept form is a terrific shortcut. Oh, that's terrible. Get the ruler out, Mr. Dueck. Is that a question? Is that a question? No? Okay, sorry, I thought I heard a question. My bad. Yes, the tongue helps. Hey, Ryan, look at number 5. Is that a line? Say yes.
Yes.
How do you know? Because there aren't any squares or cubes. In other words, even though that looks different, I can glance at it's a line. or as Prith would like me to say, a straight line. Okay? It's kind of redundant in my mind, but okay, I'm okay with that. Is the y by itself?
No.
Ah, we'll have to get the y by itself. We'll have to rewrite this. How can I get the y by itself? Well, I am going to challenge you this year, especially Jaden in the first unit, to get good at rearranging. It is Jaden, yes? Got your name right? Sorry, you looked at me weird but this is how I learn names. I just randomly spit them out. Jaden, I'm going to try and get you, especially in our first physics unit after this one, to get very good at glancing at an equation and rewriting it in your head, showing no work. And if you can do that, great. I'm going to free you up. In fact, not only am I going to free you up, if you can't do that, I'm really going to push you to get that good. I think that's becoming an expert. So I'm going to start here. How could I get the y by itself? I think, Ryan, what's in front of the y? A negative?
3.
I can plus that to that side. And it would become a positive 3y. Yes?
Yeah. Wouldn't you have to divide it?
Not yet. Patience, young grasshopper. Now, I want to get the y by itself. Can you just use your Sesame Street imagination to imagine a 9 plus 3y over a 9? I don't want that 9 there. I'm going to move the 9 over to this side, to the left side. How? What's in front of the 9? It's invisible, but a little tiny positive. So how will I move it over? Minus. So if I hear you correctly, this is the line I'm going to write. 2x minus 9 equals 3y. Is that what you've said so far? Say yes.
Yes.
And then now we're going to come full circle, Ryan. You then asked a question. What was your question?
You have to divide the 3.
Yes. So you know what? I will free you up, as far as I'm concerned, to go like this. Divide by 3. Divide by 3. I think that shows my work. I think that was organized. I can follow that, but that's most bang for least buck. You can do more than that if you want, but there you go. To me, the equation is y equals 2/3 x minus 3. In fact, I'll be perfectly honest. Trevor, right? Yeah. That's too slow for me. If I was teaching Math 10, I really try and push kids to glance at number 5 and go straight to y equals 2/3 x minus 3, and I think that's becoming an expert. I know some teachers are, show your work! I'm kind of the opposite. I'm get so good you don't need to. So hopefully you'll find that nice. It's less writing. Anyways, now what's my y-intercept, Ryan, my friend?
-3.
Yes. Slope?
2/3.
Down to, up to over 3. Up to over 3. Up to, Oh, you know what? That's line 5. Line 5 is parallel to line 1, which I also knew ahead of time, Connor, because they have identical slopes. I could have, maybe you remember doing that in Math 10 as well. Parallel slopes, perpendicular, have slopes that are negative reciprocal, all that stuff. Now, here, Mighty, I just graphed the whole graph. Usually in physics, we're going to be graphing in the first quadrant, because usually our x's and y's will be positive. Not always, but usually. If we're ever not graphing in the first quadrant, usually we're going to be graphing on the right side. Rarely will our x values be negative. In fact, if they are, we'll usually just adjust the graph because it's yucky. Those are Math 10 rules, but then there are rules for graphing actual data. On your test for this unit, on the very last question, if I haven't told you already, I'm going to tell you now, I don't surprise people on tests. So on your test for this unit, the very last question, I'm going to give you some data. I'm going to say graph it. I'm going to say find the equation. And the most common places kids lose marks is on these next few steps, so make notes of this. You have to draw and label the x and y axis in the following format. You have to tell me what it is in English, comma, what the variable you're going to use for it is, usually the first letter of the word, and then what the units are. Most common way kids lose marks on that graph question, they forget to label their axes. Okay? time t seconds, momentum p in kilogram meters per second. Wait a minute, why isn't momentum m? Because m is taken by mass. You don't know that yet, but it's usually going to be the first letter. Put your pencil down, look up. Little note, if we're graphing time, it's always on the x-axis, unless I specifically say different. There is one or two situations, Courtney, where it's going to be more convenient to put time on the y-axis, but 99% of the time on the x-axis. Select an appropriate scale. If I give you this much graph paper, and your graph takes up this much room, you picked a dumb scale. You should have gone every 2 squares, or make your graphs big, so easier to read. You can use different scales on the x and the y. Maybe on the x's you're going up by tens, on the y's you're going up by thousands. It just depends on the data that you have. Make it look pretty. Give the graph a title. The easiest title is whatever is on your x-axis versus whatever is on your y-axis. I want to give my graph a title, the rainbow unicorn. No, a title that has something to do with the graph, please. I always have some kid who starts doing artistic title. Oh, you said a title, Mr. Dueck. So I'm being specific now. Something to do with the graph. Other people have thought long and hard about how to torment their teachers like you. Next page. Plot the points. If you have a measurement with some amount of error, you draw a circle or a cross around the point to incorporate that measurement. Those are called error bars. We're not going to get into that this year, even though we know all of our measurements are going to suck. Because we know they suck, we're just going to pretend they're accurate, because otherwise our error bars would take up half the graph. I don't have good equipment. Sorry. If your data points seem as though they're all in a line, what kind of a line, Prith? A straight line. Draw the best straight line that averages the data. Do not draw freehand, but use a ruler. Now here's common mistake number 2. Look up. You can make a little sketch, but not yet. Just watch me draw this. Let's suppose you were graphing data, and Alex, you got this. Okay? There's a trend, yes? This is not how, don't draw, you would not do this. That's not the line of best fit. The line of best fit, now there are mathematical ways to do this, but to do it mathematically, really you want, Alex, either a graphing calculator or a stats calculator. What you're going to do is you're going to lay your ruler down, you're going to eyeball it, and you're going to try and just roughly split the difference. If I was drawing the line of best fit, I would probably do something about sort of like that. I've got 2 points above, I got 2 points below. Now, Ty, if you had the same data, same points, your line of best fit might be that, which is still pretty good. Because I don't have time to teach you least squares regression analysis, and I'm not going to, I would give you full marks for that as well. So sometimes you're going to see in the homework, when you're graphing data and I'm graphing data, your slope might be close but different from mine, and your y-intercept, Alyssa, might be close but different from mine. But as long as they're close, and I'll usually tell you kind of my range of values, you'll get full marks. Okay? So if you feel you need to write that down, you can, or if that just makes sense to you and you went, oh yeah, I wouldn't have connected the dots, then you're fine anyways, okay? You're going to find the slope of your best fit line, rise over run. You want to select 2 points on the line.
Grade 9 students, last name A to L, to head up to the mini gym, please. That's grade 9 students, A to L, to the mini gym.
No grade 9s in here, I assume? You're going to select 2 points on the line. You're going to find the change in y, the rise, and the change in x, the run. Find the slope. I'd like you to try and show me somewhere these calculations, either on the graph or somewhere below the graph, but in a nice ordered spot there, somewhere. Okay? Use appropriate units. Look up. Although we should technically keep in mind sig figs, we're not going to. And then find the equation of the line using y equals mx plus b, except don't use y. Use whatever letter is on your y-axis. D for distance, R for radius, E for energy. Something that, and don't use x. Use whatever variable you put on the x-axis. T for time is going to be by far the most common one. So You can see, Matt, this looks like y equals mx plus b, but instead of a y, what letter was on my y-axis? D. And instead of an x, what letter was on my x-axis? T. Oh, I did put the comic in your notes. I knew I had somewhere. Okay. Let's try one. Example. We're going to do this one together because there's a lot of little in-between the crack things you might have forgotten about. So it says graph and analyze the following data, and then analyze the graph by finding the equation of the line of best fit. Okay. What's the first column measuring? Andy. What's the first column measuring? Time. Is time going to go on the y-axis or the x-axis? First thing I'm going to do then is I'm actually going to label my axes. I'm going to go time, comma, t in seconds, and then over here I'm going to go, what do you think V stands for? Who remembers from Science 10? So we're going to go velocity, comma, V in meters per second. If you want to, you can turn your paper sideways and write the velocity this way. I have a tough time doing that on my computer screen. In fact, the last time I did that, my computer screen permanently froze sideways, and I had to reboot, so I'm not going to risk that again. Let's go back to time. Oh, title. Time versus... Actually, usually it's typical to put the y-axis first, so we're going to say graph of velocity versus time. These are easy ways that you can avoid losing. I think I make the graphing question, I think, Matt, worth 4 marks, and I take up a half mark for each sloppy thing, and the number of times kids lose that half mark for no title and no labels. We can do better than that. Now, x-axis. I want to pick a good scale. I'm going to start at 0. What's the biggest time value in my data? So I want a graph that'll go from 0 to 10. Count how many squares are there along the bottom of your graph paper. Are there 20? Are there 20? Okay. Oh, 24? So you know what? If I have 24 squares and I want to fit 10 and use as much space as possible, what would be a good scale? Go up by 2s. Okay, so I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a good scale. You saw how we figured that out? You count the number of squares and you try and fit as many as you can, but don't pick a yucky, well, I can fit 7 squares in each, going up by 7, so that's a yucky. I mean, it's not wrong, but don't make things difficult. What's the biggest V value that appears? 15. How many vertical squares are there? Oh, also 24? I guess I'm going up by 1s. Now, if I go up by 1s, I've learned if I label every square, it gets really crowded. So I'm going to go up by 1s, but I'm going to label only the even ones, because I can, in other words, I'm going to go like this. Skip 1, 2, skip 1, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Amanda, you okay? We figured that out? Yep. All right. I've done all the dirty work, all the pre-work, everything I needed to do before I graph. Now I graph. The first point goes through 2, 5.3. Now here is the disadvantage with graphing. It is very difficult when you're graphing to deal with decimals and things. You're kind of eyeballing it. It's very easy to spot the visual pattern, but a graph is not good for getting accurate data from. Okay. So 2 over 5.3, well, there's 5. I'm going to kind of maybe about there-ish, sort of, kind of. Sort of halfway between the 5 and the 6, but a little bit closer to the 5 than to the 6. But you know what? I wouldn't be that fussy. I'd be looking for something between the 5 and the 6. I'm going to make that point nice and big so you guys can see at the back. For 7.8, 7. about there-ish, I think. 6, 10.4, about halfway between 10 and 11-ish, sort of. I am already sensing a trend right now. I'm already thinking this is probably a linear graph. If this one had been like way up here, then I'd think, oh, maybe it's a curve. Those of you that are in grade 12, maybe it's a parabola, or you've seen some of those weird shapes. 8 goes through 12.8, which would be just below 13, about there-ish. 10 goes through 15 exactly. Do you think this graph goes through 0, 0? Just follow it with your eyes. Does it look like? No, I don't. There's going to be a y-intercept. And here's the problem, because we're now, I'm not going to teach you least squares regression analysis. There are all sorts of mathematical ways to actually get the best fit line. We're going to do the cheap, low-tech way, which is going to be lay your ruler down, go through as many dots as you can. Oh, and if you can't go through every dot, try and roughly have the same number of dots above your line as below your line. Split the difference. Here, I think we can go through almost every line. My best fit line sort of looks like that. And I really shouldn't have gone further past, but I'm not going to change it now. I should have stopped right on the graph. Now, I'm looking at my y-intercept. If you asked me to pick my y-intercept and tell you what it was, mine is probably about 3.1 or 3.2. Mine is definitely a little above the 3. Rebecca's, yours might exactly go through the 3. I'll give you full marks for that. Lydia, yours might go through 2.8. I'll give you full. If I was marking this for a y-intercept, I'd probably take anything between 2 and 4. But if you were telling me your y-intercept was 7, that was sloppy rule. No, right? If you were telling me that when you laid your ruler down, you ended up going through there, you have not done a good line of best fit. That make sense, Alyssa? Just letting you know how I mark these, okay? Let's find the slope. Slope is rise over run. Now, once you draw your best fit line, Alex, you now ignore the data points. You're going to find the slope of the line that you drew. So what you're going to do is you're going to find some spots on the line that you drew where it goes through the grid exactly. I'm going to zoom in for a second. Watch, here's what I mean. I'm going to put a couple of big dots to try and find a good point. You know what? I think I'm going to put a dot right there because it looks like on my line, I go through the grid right there. And then I try and find another one fairly far away. So I'm going to go look up here. Would I want to put a dot right there? No, Courtney, because it's not on a grid line. I'd be guessing how high I am. No. You know what? Actually, I think mine goes through right here. So I'm going to use these 2 points as my rise and my run. Yours now are going to be different. What you need to find on your line is 2 nice points that your line goes through. So now you can't copy mine. You got to go look at yours. Then I tend to, with a pencil or a different color pen or something, I like to draw a little tiny dotted line triangle. That's my slope triangle because I've learned by doing that, that cuts down on mistakes. It helps me find the rise and the run easier. My rise is, let's see, from 5 to 14. My rise is 9, 5 to 14, yes. And my run is 9, 1.5. Okay. 9 minus 1.5. And in physics, we write slopes as decimals, not as fractions. So my slope, and yours should be fairly close to this.
Please.
Mine is...
Grade 9 students with the last name M to Z, please head to the mini gym. Grade 9.
I would
M to Z to
suspect
the mini gym.
that
Thank you.
most of you are getting a slope between 1.0 and 1.6 or so. I'd take that. If, Connor, you're telling me that your slope is 0.3, you did a lousy line. Or you've done something wrong with your rise over your run. And again, be very, very careful. Every time, I also have kids, they just count the number of squares. You'll notice I didn't count the squares because I think the number of squares is 15 squares, but every 2 is 1. Every 2 squares is worth 1. Question, Court? You good? Okay. And I'm also going to write here B equals, for me, about 3.1. So again, your equation, Trevor, is probably going to look a little different from my equation, but should be close. Or some of you might be bang on mine. I don't know. Could be. The instructions said analyze the graph. Done. Write the equation the best fit. Here we go. So we're going to use this as a template. Y equals mx plus b. Except what letter should I use for my y-axis? What did I put on there? V. V equals, what's my slope? 1.2. What letter should I use instead of x? T plus 3.1. I'll put a box around it. This is my line of best fit. If I gave you this question and I was marking it for the slope, you'd take anything probably between like 1.0 and 1.4-ish, give or take. And are we all okay there? And then I'd take for your y-intercept anything between about 2.5 and 3.5-ish. It's all in how you lay the ruler down. Is that all right? Now let's answer the questions. A says, what is the y-intercept? Well, for me, 3.1. For you, I don't know. What does it mean? What is the y-intercept telling me? What when time is 0? When time is 0, my speed or velocity is what? What did you call the velocity that you started with? You talked about this in Science 10. Ah, Prith. You've made up for your straight line. What was that? Okay, you know what? This is telling me VI. Or if you want to, you can write down initial velocity, but we'll never write that again. From now on, we're always going to abbreviate that as VI. It means this car was moving before we started timing it. What are the units of the slope? Slope is what over what? Slope is what over what? Once again, slope is what over what? One more time. Slope is what over what? Everyone? Okay. Look at the units. What are the units on the rise, on the y-axis? What are the units on the y-axis? Meters per second over, there's your rise. What are the units of the run? Who remembers from Science 10, what is meters per second per second? Acceleration. Some of you might have memorized all those graphs last year. You're going to see a lot of graphs this year, especially in Physics 12. You're not going to memorize any of them. What I'm going to teach you, Jess, is how to figure it out from the units. This is meters per second squared. Hey, the slope of this graph is the acceleration. The slope of a velocity time graph is the acceleration, which you might have memorized last year. You still can memorize it this year, but Trevor, I've also just showed you how you can derive it if you know that slope is rise over run. And that one you all have memorized. Okay? Pause for a second.